Hello everyone, welcome to Experiments with Big Brothers Big Sisters. My name's Logan and today we're going to be doing experiments with water and liquid density. It sounds boring, it looks really cool. Before we get into the actual experiment, I'd like to say thank you to ExploreNet for sponsoring the boxes for April, May, and June. Without you, ExploreNet, we wouldn't have the funds to be able to get all our activity boxes out. So thank you so much for making all of this possible. So what you'll need for this experiment, I've got a general mixing beaker sort of. I've got a large reservoir of water because we'll need that. I've got 3 individual containers. I've got a spoon for any sort of retrieval. We're going to need some dye to tell the difference between some of our liquids. I've got oil here and corn syrup here. We've also got a raisin, which is going to float. And then we've got a basin of salt and a basin of sugar. Before we go any further with the experiment, I have to explain 2 key terms, volume and density. Now, volume is the amount of space something takes up. Density is the amount of weight contained in that space. So despite things maybe being the same size, they can actually weigh different amounts. Consider comparing a bouncy ball to a round ball of metal. The fact that things that are the same size or volume can weigh more than each other is best evident in something like this. I've got a little fabric bunny, which is probably about the same volume as this star. You can see they're similarly sized, but this star is a great lot heavier than this bunny. That has a lot to do with the materials they're made out of. This bunny is made out of cloth and beans, and this glass is made out of heavy glass. While this might seem obvious about solid objects like that bunny and that starfish, well, liquid also has density. Different liquids sort of weigh more in the same amount of volume than other liquids. We'll see this with water, corn syrup, and oil. So I've got my water here, my corn syrup here, and my oil here, and you notice I have about the same amount of each. Now, you might already have some guesses about which liquid is denser. If you look at the water, you can see it sloshes around quite a bit. But if you look at the corn syrup, look how slow that moves. Obviously, there is some difference in the density of these objects. But a great way to tell how dense a liquid is by putting a light object in it and seeing if it floats. That's where our raisins are going to come in. You see, the denser a liquid is, the easier it is for objects to float on top of it. So let's place a raisin in each one of our liquids and see which allows it to float the best. Start with water. Looks like it sank all the way to the bottom. We'll go to corn syrup. It's staying right on top. And oil. It appears our raisin is sitting at the bottom, but let's try another raisin, maybe a little bit later. You can see while it floated right to the bottom, it had a little bit of difficulty doing so. So despite the fact that we have the same amount of each liquid, it's very clear that the water is a lot less dense, a lot less heavy within its given volume than the corn syrup and oil, mainly because the raisin went right down to the bottom of the water while it floated on top of the corn syrup and was resisted by the oil. Another neat way to tell the density of a liquid is by pouring them all together in a beaker. Now you might think, they're all going to mix. Well, as per the density of liquids, we'll just have to see. So what you want to do is pour all of your liquids into a single beaker, let it settle, and see what happens. After a little spill mishap, and of course some experiments will get messy, we've let our liquid settle and we've ended up with this. Now it might be sort of hard to tell, but if we zoom in, we can see on the very bottom there is our corn syrup, meaning our corn syrup is the densest because it went all the way to the bottom. It's a little hard to tell between the oil and the corn syrup, but there's actually a clear layer there. See, it's easy to tell right there. That means our water is actually denser than our oil. If you look at our top, it's sort of looking a little greasy. That is our oil on top, meaning that since it floated to the top, it is our least dense liquid. Isn't it cool the way they separate, even though you'd expect them to mix as liquids? Pretty neat. Now, the density and makeup of liquids can actually have some pretty important real-life consequences. When big oil tankers spill oil in the ocean, it can be incredibly hard to clean up because that oil is such a different mixture than the water. It can't just be drained with the water, it has to be collected specially. And so these kinds of experiments really affect real-world things. Oh, and just for fun, don't forget to drop a raisin in there to see what happens. You'll see it has penetrated the first 2 layers of our liquid, but is floating right on top of our corn syrup. Nifty. Now that we've established that different liquids have different densities regarding the same volume each, we have to ask the question, does anything change that density? And the first thing we're going to apply is temperature. Will something's temperature, whether it's hot or cold, change the density of that liquid? Let's have a look. To answer that question, we've got a glass of mostly hot water and a glass of, as you can see, ice water. Now what you're going to want to do is grab that food coloring from before and make each of these a different color so we can tell them apart when we mix them. I'm going to make my cold water blue. That seems appropriate. And I'm going to make my hot water red. Just like when we combined the oil, corn syrup, and water, we should expect for something to happen here. These liquids maybe should not mix together because they have different properties. One is hotter than the other. Let's see. Now, if we pour these too quickly, we're going to end up with purple Kool-Aid on our hands.
Do we see any difference?
So I want you to start out with your cold water, blue water here, and we're going to very carefully, drop by drop, add the hot water to the blue water. Hopefully we won't get purple water, but it might take a few tries, so be patient. Now, it's very hard to tell on camera, but there are wisps of red rising up onto the top of my water. You can just barely catch it. It doesn't look like individual drops. It looks instead almost like a cloudiness of red. But the reason this is that hot things want to rise. Hot things are less dense than cold things. Thus why they tell you to get on your hands and knees in a fire, because all of the hot air, the carbon dioxide is going to rise to the top of the room because it is less dense than the actual oxygen in the room. So, in short, cold things sink, hot things rise. Now, our last experiment with liquid density is going to ask the same question as before, but instead of changing temperature, we want to know if adding something to the liquid will make it less or more dense. Here, we're going to play around with salt, sugar, and pure water to see if any of those affect the density of it. We're going to use food dye to our advantage once again to help us determine which liquid is which. Now I've put 2 teaspoons of sugar in this one, 2 teaspoons of salt in this one, and I've left this one untouched. So for the purity of our right one, we're going to use the color green. For the harshness of our salt, we're going to use the color red. And for the yummy blue raspberry flair of sugar, we're going to use blue for our sugar glass. Now you can go ahead and mix in your water, and we'll go from there. Now to test the density of these different water mixtures, we can of course go back to the classic raisin trick. So we're going to plop a raisin in our pure water, we're going to drop a raisin in our sugar water, and we'll drop a raisin in our salt water. Now they seem to have all sunk, which means that it seems the salt and sugar haven't made the water dense enough for the raisin to float on top. But that doesn't mean they haven't made any changes. To test very minutely which one is more dense than the other, we're going to go back to attempting to mix them. Now remember, because these are very similar in density, they are both water, you want to mix it very slowly as not to end up with purple. So take your spoon and add just a little tiny drop at a time. Now it's going to be very hard to tell, but you can see actually that the top is a little bit darker than the bottom. That means that our blue has purpled the top, but not the bottom layer. That means that since the blue is above and not below the red, the sugar water was more dense. We can of course test this again by using our pure water on both our salt and sugar water. So I recommend you take a spoon and again very carefully add drop by drop a little bit of your pure water to each blend. It's going to be extremely hard to tell on camera once again, but what I noticed up close was that since the pure water has nothing mixed into it, it stayed on top of the other two solutions, just because it's pure water, very, very not dense. Now, of course, it depends how much sugar or how much salt you put into water. Now, when there's only a little bit of sugar and a little bit of salt in water, salt water is usually denser, but if water is super concentrated with sugar to the point where it becomes something like corn syrup, it's actually a lot denser than something that has a ton of salt in it. Pretty interesting how that works. Now if you want a real life example, there's actually a sea that is so full of salt that people can just float right on top of it without even trying. It's called the Dead Sea. Mostly because hardly anything can live in it because it's so salty. People just float right to the top. It's pretty cool. Well guys, thank you for joining me for this experiment. I hope you've learned a lot about liquid density. Not only that liquids are denser than other liquids, but also that things like temperature or salt or sugar can affect a thing's density. I'm sure your experiments are going to look a lot better in person than on camera, and I'm very excited to see how they turn out. Hope you guys have enjoyed April boxes, and for those of you who get it, we'll see you next month in May. Have an excellent rest of your April, everyone. Take care. Bye-bye.